Thank you all for joining me today. I am pleased to be here in Cypress's company as a daily active user, a frequent beta tester, and a Cypernaut. I'm excited to have this conversation with you called How Simple Cypress Tests Recouped Thousands of Company Dollars. My name is Jessica. I've spent over 7 years working in quality engineering, helping teams shift left, embrace testing practices, and build confidence when shipping work to production. So you may be interested to hear that my topic today is about making the case for staying right with a heavy emphasis on operations. Sometimes breaking with convention can literally pay off. You often hear about shifting left, the gold standard of automated testing. It empowers developers to test their own code, catching defects early before they reach production. But what happens when shifting left isn't immediately feasible? When resources are limited or quality engineers are focused further down the development lifecycle? In this case, both challenges applied. Quality engineers were separated from product engineering, making cross-team collaboration difficult. Perhaps you can relate to this. It turns out impact can still be made without embedding directly in product pods. That's where testing on production comes in. Today's discussion focuses on a Cypress suite built to monitor production and the key decisions that made this approach not only possible, but transformative. This system would ultimately boost developer confidence and became the first line of defense against defects, both in-company and even for external providers. Now, onto the case study. When this project began, customer complaints were high and site uptime had lows. Shifting left was the long-term goal, but we needed impact immediately, so we chose to test directly in production where we had the most control. End-to-end tests are complex, often verifying a user journey or a business process that spans multiple steps and subsystems. Against an unpredictable system under test, they could be slow, brittle, and hard to maintain. The aim is to make them fast, isolated, and able to fail quickly. Remember, fast, reliable, in budget. I created a dichotomy between end-to-end tests and end-to-end flows. For example, asserting that a video player component renders on a web page is an end-to-end test. Purchasing an item from an e-commerce site is both a test and a flow. Now onto the mental model that guided our implementation. Here is the mental model in its final form. This mental model became the blueprint for onboarding future developers to the automation suite. It creates the construct of the project. The model was this. Level 1, verify that the site and web page are available using Cypress's Visit. If this fails, the suite exits and sends a signal. Level 2, assert that key features are present. If these tests are flaky, the system needs stabilization. Level 3, test end-to-end flows, interacting with buttons, forms, and multi-page consistency. This may include internationalization, for example. Level 4, automate complex systems like email templates and discussion threads. Automation would begin with levels 1 and 2. If the requirements for 1 and 2 are not met, do not pursue levels 3 and 4. Levels 3 and 4 rely on levels 1 and 2. Without them, end-to-end flow is futile. Picture fishing. Level 1, check the weather. If it's bad, don't go fishing. Level 2, cast a wide, shallow net. Catch common defects. If the tests are flaky, stabilize the system under test. Level 3, use specific bait. Target bigger, trickier issues. Level 4, cast multiple lines. Discover deeper, hidden problems often. With the problem space defined and the mental model intact, Hello World could begin. Using the mental model, Hello World was kept simple. Using Cypress's command library, the Cypress test runner visits the web page using CyVisit, establishing page availability. That's level 1 complete. Next, level 2 would execute. Level 2 tests were basic. Check that the video autoplays on page load. Check that the video player controls are present. Level 3 was strictly excluded from iteration 1. There was no engagement with the video player at all. This marked the first end-to-end test monitoring the video player in production. We immediately began catching defects, specifically tied to the autoplay functionality. If the video didn't autoplay upon page load, the tests failed. This simple but effective test set was scheduled on a cron job in CodeFresh, running every 20 minutes. Cypress was frequently signaling that the video player in production was failing to autoplay. The only problem was that the signals were frequent and noisy. They'd signal several times a week. This raised a key issue, resilience. Yes, we want to know if the video player is defective, but to what end? Alerts that self-resolve can lead to alert fatigue and system distrust. We began referring to dead signals as transient errors and false positives. The rate of dead signals was high and needed reduction. The new challenge became, how do we filter out these transient errors and only act on true defects? Remember, all signals surfaced by your automation framework should be actionable. Inactionable signals are waste. To build resilience, we implemented retries. What's more, we layered defense mechanisms at the continuous integration layer known as defense in depth. There were now 2 layers of retries in the system. 1, the code layer. Cypress's retry option placed directly in the configuration code. 2, the GitOps layer. Cypress test sets execute twice in the CI pipeline. This configuration helped to surface special cause variation and mute common cause variation. A brief interlude on common cause and special cause. Common cause versus special cause variation would serve to become our magnum opus. Transient errors are inevitable as applications are complex, relying on various networks, libraries, and external dependencies. While every component of a system should coordinate to deliver an aim, they may not do so perfectly. Let's use a river, for example. Common cause variations are the normal shifts in the system. These are expected, predictable changes. The river is higher after rainfall and lower after dry season, but it usually remains in the confines of the banks. Special cause variation is the uncommon occurrences of a system. If a storm occurs and causes extreme flooding, the river rises above the banks. Nearby grass is now marshy and muddy. We can't precisely forecast how much flooding will occur with each storm. As we delved into the GitOps layer, understanding these variations will guide us in building more resilient systems. By distinguishing between common and special cause variations, we can enhance our approach to error management and improve overall application reliability. Here is the CI layer in code, the code-based version of the earlier visual. There are 2 steps in the definition, first run and second run. In the first run, all Cypress tests are executed unconditionally. If successful, the pipeline concludes with no further action. The second run, execute only if the first run fails. If successful, no action is taken. If it fails, a PagerDuty incident is created. This approach is language agnostic. If a test fails at the code level, retry it. If any test fails in the first run, retry the entire suite. If both runs fail, notify an engineer. Not pictured here, is the PagerDuty API logic that creates an incident when the second run fails. That conditional logic follows this same pattern. Something funny happened when we used this conditional logic. It revealed an opportunity. Not only did we not want to know about first run failures, we did not want to pay for them either. The first run uses the record false argument, meaning these runs aren't recorded in the cloud. Only the second runs, triggered after 2 consecutive failures, are recorded. Cypress charges based on unrecorded test results. By only capturing second runs, we incur charges only when there's an ongoing defect. That meant second runs could be studied and replayed in Cypress Cloud. First runs could not. But that's okay. We don't need to review first runs. A simple yet profound idea. When we were paged, we knew undoubtedly that it was a real problem, and we could be certain that the Cypress bill would remain in budget. Instant investigations began immediately with clear calls to action. With this control in place, we opened the door to variation control in multiple directions. We could accelerate the cron job and enhance our GitOps processes, repeating this as many times as needed. With cost control and resilience built into the system, suite expansion could continue without compromising our budget. And it did. Using the level 1 and level 2 mental model and defense in depth, we achieved broad coverage across the site. Cypress scripts monitored critical areas such as authentication, search functionality, and statistical payouts. Previously, the payout statistics experienced frequent undetected downtime. Now, alerts were generated to prevent missed payout periods. Customer happiness was amplified. We could quickly extend coverage for new features with feature gating to ensure continuous verification during launch time. Quality impact was magnifying. Each time a PagerDuty incident was created and delegated to a product team, they had confidence that it was a valid signal. All of this could be done asynchronously, and production was under 24/7 cost-protected surveillance. So now that the system under test was under constant surveillance, how could we ensure that the testing system remained under constant surveillance? The testing system is a system in its own right. It too is fallible. It depends on Cypress Cloud, Yarn, and more. To build reliability, my SRE partners and I developed main and ancillary indicators to monitor suite uptime. We defined operational checks using bash scripts, which were then integrated as steps in the CI pipeline, reporting results to Datadog. For brevity, this slide includes only the first verification check. There were 3 modes to begin. Mode 1, fail if Cypress reports directory is not created after a test run. Mode 2, fail if JSON report files are not created in the Cypress reports directory after a test run. Mode 3, fail if the number of JSON report files does not equal the amount of test spec files. They should be the same. The acceptance criteria could extend beyond these initial failure modes. We could continuously add more checks as needed, such as verifying that recordings are uploaded to Cypress. In the updated YAML file, we have introduced 2 new verification steps surrounding the test run processes. Both verification steps call the verify test run file, which contains the bash logic outlined in the previous slide. Now, let's revisit our GitOps flowchart to see how these changes look integrated into the overall testing workflow. Pictured is the new resilience and retry structure. These two new verification steps are placed between the Cypress test sets. These steps would check that each test run completed. They would also act as timestamps that could earmark execution beginnings and endings. These verifications would become the impetus for substantial Datadog monitoring on the testing system. Future improvements may include alerting only when the same tests failed between the first and second runs. With the new batch steps incorporated into GitOps, we could leverage that information within Datadog to create graphs and telemetry using Datadog's CI visibility feature. The derived graphs would tell us the following. 1. Pipeline duration. Monitor the median, P90, and maximum execution times to ensure the pipeline completes within 20 minutes. If it exceeds this threshold, trigger a signal. 2. Verification count. Track periods when the Cypress suite did not run. We expect a test run rate of 6 runs every 2 hours. If this rate is not met, trigger a signal. 3. Second run execution rate. This metric indicates the frequency of the second runs, which occur after first run failures. It helps us understand the occurrence of transient errors. Note that there are no alerts for this metric. We review it passively during weekly ops reviews. Remember, transient errors are not actionable. True positives were growing, achieving an average of 3 incident reports per week. The objective was to fine-tune the system continuously to ensure that all reported incidents were true positives and required routing to a product pod. We employed a straightforward measurement approach using a ratio analysis. Of all incidents, how many were true positives? This allowed us to evaluate and refine the effectiveness of our monitoring and alerting processes systematically. We eventually reached a rolling monthly average of 100%. That being, for every incident received, each was a true incident requiring a response and a resolution. With production monitoring fully operational and our systems functioning as intended, the opportunity to shift left was now available. Multi-environment support was configured. The Cypress suite could be pointed towards staging and sandbox. In this code snippet, the getConfig function combines environment and base configuration. We manually integrate the end-to-end and end settings in the base configuration, ensuring that only the essential values are overridden. This configuration structure remains flexible, allowing for the easy addition of new environments without the overhead of deep merging. The Cypress env environment variable controls the active configuration, defaulting to staging if no specific environment is set. By adopting this approach, dependencies were minimized and cross-environment testing was enabled. Future iterations of the suite would include automated product pod routing using test tagging and PagerDuty integrations. The signals were so reliable that product pod routing was being requested. Tests and their respective signals were dispatched directly to the product pods using a tailor-made tagging and PagerDuty routing play. Each pod was fitted with their own Datadog observability dashboard to visualize that their code and tests were working as expected. They were equipped with the level mental model and deployment pipelines that they could own and operate. They could go as deeply as their code would tolerate on higher level testing in levels 3 and 4. They could begin to experiment with TDD. Shifting left could begin. And it took about 5 months to go from hello world to total formalization. So what did this all amount to? Cypress Suite was responsible for catching 50% of all leak defects in 2023 and counting for 2024. It reached 100% operational efficiency as measured by our monthly metrics. The Cypress Suite would signal for all downtime, not only for Skillshare, but for our third-party providers like Auth0. There were points at which Skillshare caught and reported downtime that SaaS providers hadn't yet. In one case, authentications were failing app-wide. We were able to trace it back to Auth0, our authentication provider. As determined by our Auth0 SLA, downtime of only up to 10 minutes was tolerable. Any more than that was a violation. In one case, our observability allowed us to pinpoint the exact moments of downtime, enabling us to collaborate with vendors to uphold our SLA and recoup over $6,000. This happened 3 times in 2023 with numerous enterprise-level SaaS providers. Had this testing been done on Sandbox or staging, this money win-back would not have been possible. Ultimately, the Cypress Suite matured into Skillshare's premier monitoring system, eclipsing even existing Datadog monitors. The success of the Cypress Suite fundamentally transformed our testing and development processes. The high performance and indisputable incidents became invaluable assets to the engineering organization. Developers began requesting greater control of their tests and signals. They wanted the ability to tailor their testing environments and strategies to fit their unique workflows. Cypress and how it was used was ultimately pivotal to the organization's testing schema and remains the leading tool for ensuring high-quality software delivery. Thank you all for your time and interest today. I hope to have left you with some pro tips to use in your work with Cypress. And my sincerest thanks to Cypress for having me. If you'd like to continue the conversation, my socials are included here. Now for any questions.
Thank you, Jessica. That was an awesome presentation. Really enjoyed walking through the case study that you presented. As we bring up the first audience question, I was curious to find out what impact this observability implementation had on the culture of testing at your organization.
I think it goes even beyond just Datadog monitors. It was deeply on several layers of impact. By having the monitors, the impetus began to review the monitors, and we would do so during weekly ops reviews. Not only that, but became a coaching opportunity for a lot of the folks who know deeply about telemetry and observability to teach others about it. It itself is a science, and knowing what types of verification to implement and then actually implementing it using something like Bash is really invaluable. It was one of the best things I've learned. And I think, just determining what you'd like to measure. We would refer to those as tier 1 and tier 2 signals. And then learning how to translate it into the Datadog language in telemetry, and then visualizing it week over week created this real accountability for your system.
That's incredible. We have a number of questions from the audience, so I'm going to bring up our first one. This is regarding a specific part of your presentation. Do we segregate these levels on an individual test or on separate test?
I will try to answer that this way. First and foremost, all tests are meant to be isolated always. So Cypress has a fantastic test isolation argument included in their configuration from their library. So that's the first thing to always keep. And then in each of the test spec files, you might have several levels. You might have level 1, which of course is it's inevitable, like you must visit some page to go and test it. But once you do that, of course, you've established availability, so then you can go further. You would then do level 2, and you could check any number of components on the page, whether they're visible or not. And like I said, in order to even go further for something like, does the video go into full screen mode? The video needs to be first present. So if then you were to use the same test set to go into full screen mode, then you would be engaging level 3. Likely, level 4 would be done entirely separately. Level 4, doing things like testing email templates in MailChimp, for example, requires API interceptions and a lot of posts and a lot of post requests. So you would do that likely outside of any of your fundamental test spec files. And of course, like my sort of motto is always to keep your test to a single assertion. That way, if it fails, you know exactly why. And furthermore, if you have a test with multiple assertions and it fails, it will not test the remaining assertions. It will exit at the first one. So you will still not get the benefit of the remaining assertion tests. So I hope that answers the question.
I think it did. Thank you for the insights there. I'm going to bring up another question from the audience. And this is about your all's approach to ignoring that first try. Did you find that this is masking any flaky or unreliable tests, or how is that accounted for? Like, what benefit does skipping that first try give to you all?
There are many benefits. The first is like reduced noise. Mm-hmm. And just to be clear, if the first run passes, we want to know that it's passing, right? That's why we have the Datadog monitoring. We want to know every 2 hours, we want to see that there's been 6 runs, right? And that rate tells us that the first run has completed in the amount of time we expect it to. So while we're not looking to be signaled by first runs, we want to know that they're happening. If they're not happening, then there's an availability problem with the Cypress suite. Flaky tests are measured elsewhere in Cypress Cloud, so they too can be reviewed on a weekly basis in weekly ops review. That's part of like in your weekly ops review, including flaky tests. My policy is if there are flaky tests, they're fixed immediately. And Cypress Cloud does an incredible job of those analytics. I can see at any moment in time when a test has been classified flaky as per Cypress. So no, the first try fails is really separate. It's like the first run, the second run. Flaky tests are an entirely different methodology, right? Like we don't ever keep flaky tests.
Excellent. Another question from the audience. You've presented a really interesting case study and advanced system and testing methodology that your team has put together. Can we think about how that would apply to a complex application where Cypress has not yet been implemented? What are maybe some tips you have for getting started down a path like your team has put together?
Well, I would say that Cypress is just a tool. It's a preferable tool, in my opinion. It's a powerful tool. It does a lot of the debugging work for you. So while I used Cypress, we also began with nothing. So, well, I shouldn't say that. There was testing, but this was the first iteration of the new testing system that used Cypress. And in this case, it was on a complex application. So in my response is to follow the same guide, implement the same policies, use the level approach, use visual management to arrange all of your web pages by level 1, arrange the features by level 2, and gamify it, flip them to make them green, like write tests for them and flip them, see how many level 1 and level 2 components can be tested, and then proceed to level 3 and level 4. Of course, you could choose another application, Cypress Cloud. Aside from Cypress Cloud, it's just my preferred software, and it's a great company. So it does a lot of the work for you.
Excellent. We are going to go ahead and work towards wrapping up our first day of Cypress Conf. Jessica, thank you so much for hanging out with us, for sharing your insights, for presenting this case study to us.